We're looking at an introduction to version control. So this is Git based, and this is just purely theoretical about how Git works, not on actually how to do it, but with this knowledge it's super easy to work with. So this is all based off of Skillsoft. This is just what I'm taking and summarizing from it. So Git is a distributed version control system tracking source code changes during software development. And version control is a system that records changes to a file or set of files over time so that you're able to recall specific versions later. An example of this is if we have code that describes like cooking something like tea. So you boil 200 milliliters of water, add 2 teaspoons of tea leaves, brew for 5 minutes, and then drink the tea. That's the initial version. Well, let's say that adding sugar improves this. So we want to have the code now implement a add sugar. So we can do this and push this to our Git. We can commit this there. And then if we ever want to go back to the old version, we can still do that because we have access to both. So we see that we have T recipe text v1, v2, and v3. These are just the different versions, and we're able to access all of them whenever we want. Now, we don't record the entire file over and over again. It's not efficient. Instead, just the changes are saved. So it's not going to really look like this. We're going to record the deltas. So it's going to look like this. Just the changes in each thing. Now, just some notes from the Skillsoft. Changes should be recorded in a concise manner. Every version should be recoverable using original file and the recorded changes. It should be possible to roll back changes as well, and comparing versions should be easy. So if we have something like this, our T recipe text v3, which is all of it together, would be equal to all of our changes plus the original recipe. We have some features of Git. We have code stored in a repository. For Git, it's going to be online. When downloading the entire repository, which is the history, it's cloned to our workspace. We can record or commit changes to the local repo even when we're offline, because the local repo is like our machine. The remote repo is where it's being stored, where everything's being stored, where we got it from. When we're ready to share our code, we can push our commits to the remote repo. So we go from our local to the remote. It's backwards. A summary of this is that Git, we have distributed version control. It's free and open source, small and fast, and we can have branching and merging. So let's further look at branching and merging in Git. Multiple teams can work independently on their own copies of the repo. So let's say that we have two people, like Alice and Bob. They have original source and they can take it, they can clone the remote repo and work independently on their local repos. So after this, they want to push back to the remote repo. This can be done. Commits are actually recorded in a branch though. The main branch of a Git repo is called the master branch. And a branch is a series of commits. So we have initial commits, we have all these commits, and then we have a master branch. It's this solid line if we were to represent it as like this chart. And then we have this Alice branch and Bob branch. Now each member will clone their respective branches. Once their work is complete, they commit and push to the remote branch. So we have our, again, Alice branch and we have our Bob branch. Each feature branch is different from the master at this point. They're both working on separate branches. Now, they can merge it with the master. On services such as GitHub, merging can involve a pull request. So what if we have a conflict during our merge? Well, the conflict will prevent Bob from merging his changes if there is a conflict with the file that Alice has merged. To fix this, the merge conflict must be resolved. So there's no single solution. We can accept the changes made by the other team or overwrite them with our own. We can work out a compromise. Tools are also available to help with merging conflicts. So let's look at hosting Git repositories with GitHub. So we just have some summary here. A hosting service for GitHub repositories. It's accessible at github.com. It's owned by Microsoft and includes a free and also a paid service. So free for like individual users and paid for more enterprise stuff. We have online file reading. We have branch visualizations, a user administration service, control access to source code and assigning roles, a pull request feature so we can let collaborators review code before it's merged, integration with our CI and CD tools, and we can kick off the workflow code once it has been pushed. So another summary of this is a request for one's contributions. A summary for this is that a request for one's contribution to be added to a branch is typically created with merging to a master branch. It effectively enforces a code review. We know that we want to review the code before it gets pushed to the master, make sure there's no conflicts or anything, and make sure it's correct. And rules can be assigned for approval of a pull request. So you could like vote, have like a 3 out of 5 votes to see if this can be sent to the master branch in our pool. Let's do a test real quick. Which of the following is not a property of version control systems? Well, they enable comparisons of different version files. We know this is true. They do record large changes made to the code, large or small, and they enable rolling back code changes. So the only one that's not a property of version control systems is that they make our application code run effectively. That's not property of Git. Which term is used to denote creating a local copy of a remote Git repository? We have push, sync, and rendition. So we didn't go over sync and rendition. We know pushing is actually getting our local repo to the remote repo. Now clone is where we get a local copy of our remote. Which statement accurately describes a merge operation in Git? Well, creating a local copy of a remote repo? No. We are not deleting an unused branch. We haven't even talked about that. And we're not overwriting a local repo with a remote one. Which statement accurately describes a merge operation in Git is when we push commits from one branch to another. That's a merge. When we're pushing branches together, we're merging them. Lastly, which of the following is invoked when merging one branch on GitHub into another? When we're merging one branch, we have to have a pull request. We don't have a commit confirmation, a code freeze, or a git clone, just our pull request. And that's it for our small test.